this lesson I want to continue with kinematics of linkages, and what we're going to talk about is constructing a kinematic diagram. Kinematic diagram is really important. You should understand why you're constructing one. The first reason for constructing a kinematic diagram is to kind of peel away and abstract out all of the physical elements of your system and create a simplified diagram such that you can analyze it. And the kinematic diagram allows you to analyze the degrees of freedom of a system. Also allows you with a compass, ruler, and protractor to begin to understand the motion of your system. So we'll go through the way to construct a kinematic diagram. The first is the convention. You need to ensure that you're numbering the links with numbers, and you should get in the practice of numbering the frame or the ground number 1. This will be for consistency's sake for me as well as you. Name the joints with letters, and we'll capitalize these letters. It's important to note that a joint is between 2 and only 2 links. Okay, so a joint is between 2 links, and so if you see, for example, we've got a link here, we'll call that 2 because it won't be the ground, and we've got a link here, we'll call that 3. There's a joint A. Okay, that joint is between these 2 links. If we were to have another link here, okay, and this is 4, okay, it's 2 joints, A and B, okay. The first joint A connects link 2 to link 3, and the second joint B connects link 3 to link 4, okay. And what you're essentially looking at here is the following. If we were to blow this up under a microscope, okay, we'd essentially be looking at a situation where we've got link 2, link 3, and link 4, and joints A and B. Okay? So that's essentially what we're looking at in that situation. Okay? And then we've got points of interest, which a little bit different than we spoke last time. We'll use lowercase and start at the end of the alphabet. Okay? So let's see what a kinematic diagram looks like. So here we have a shear mechanism, and this mechanism operates, we've got this part here and this part here mounted to a table or bolted to a tabletop. We've got a shear mechanism. Here's a piece of sheet metal, and then here's the handle that moves up and down. Okay. Let's go ahead and look at this in the context of a kinematic diagram. The first thing is we're going to identify the frame. Okay, so this part is the frame. Now what you'll notice is the following. We've got the left side and the right side of this device. There's 2 separate pieces. There's 2 separate pieces. There's always only one frame. Only one frame. Always. Despite the fact that physically these are 2 pieces, there's always only one frame. Second piece, we can identify all the other pieces and identify the joints here. So we've got the handle. Okay. So we'll label this frame 1, the handle 2, the coupler 3, and this blade here is going to be 4. And then we can identify the joints. Okay, so we've got joint here, joint here, joint here, and then this square rectangle is a sliding joint. Okay, and then we've got a point of interest here, and what we might be asking is, in order to get a certain amount of displacement of the tip of this blade, how far does an individual have to move? And finally, that results in this kinematic diagram. So what you'll see here is the following. 1, that is the frame or the base. 2 is the handle. 3 is this coupler. 4 is the blade. We've got A, which is a joint between 1 and 2. B, right here, which is a joint between 2 and 3. C, which is a joint between 3 and 4. And D, which is a joint between 4, the sliding mechanism, and 1, the frame. Okay, so that's the kinematic diagram. This is an abstract representation of reality. Okay. So what I want you to do for this toggle clamp is hit pause on the video and create a kinematic diagram for this toggle clamp. Okay. You can take some time to do it now. Okay, so hopefully you've taken some time. If you're not finished yet, we'll go over it here. So what we've got is a 3D object, but really we're talking about a 2D representation. So you can see this item here in the middle is bolted down to the table, so we're just going to identify that as 1. We're going to identify this handle as 2, this coupler here as 3, and then this business end as 4. And then this is going to be joint A, joint B, joint C, joint D. And our kinematic diagram will look something like the following. I'm going to start with the handle. The handle comes down. There's A. Okay. And then I've got that's D. That's B, and that's C. And what I like to do is represent the ground similar to how you would represent it in ME201. And we've got these ground. So there we go. There's your kinematic diagram. Let's label the links 1, 2, 3, and 4. Okay. And with this kinematic diagram, we can compute mobility. I have not given you the equation yet, so we'll do this in the next video. But we got the kinematic diagram. We can identify all the links and all the joints. So this is great. So we'll pause here. In the next video, we will go through calculating degree of freedom.